Moving on to our third example under application of calculus. We're given a closed cylindrical water tank which is made up of a sheet of a metal. The volume of the cylinder is 2000 centimeter cubes. We are required to express the height of the tank in terms of the radius r. So we're quickly going to do these ones. The first one, remember, we're required to do what? We're required to express the height of the tank in terms of the radius. What is it that is given to us? We're given the volumes. Therefore, we're given the volume. Therefore, we're going to use the formula of the volume to represent H in terms of R. The formula for calculating the volume of a cylinder, where V is equals to what? V is equals to pi R squared H. Pi R squared H. Remember, volume is what? Volume is the area of the base multiplied by height. So the area of the base, area of the circle is pi R squared multiplied by height H. The volume is given to us. It is 2000 centimeter cubes, which is equals to what? Pi R squared H. So remember, we're required to express height H in terms of radius R. So we want to make H subject of the formula. So we're going to divide by pi R squared there, divide by pi R squared there. So pi R squared will cancel pi R squared. We're left with H on that side. So the height of the cylinder in terms of R is 2000 divided by pi R squared. Moving on to the second one. Show that the surface area of this cylindrical water tank is 2 pi R squared plus 4000 divided by R. So we're going to write down the formula for calculating the surface area of a cylinder. It is SA, which is equals to 2 pi R squared plus 2 pi R multiplied by what? Multiplied by height. This 2 pi R squared, it represents what? Represents the top of the cylinder and the bottom of the cylinder. So we're going to use 2 pi R squared because this cylinder is said to be closed. It is closed on top, it is closed also at the bottom. Plus 2 pi R H. That one, it will be the outer part of the cylinder. So we have 2 pi R squared plus 2 pi R, but what is our H? Here's our H in terms of R. So for H, we are going to substitute 2000 divided by what? Divided by pi R squared. So we're going to simplify that. We have 2 pi R squared plus what now? Pi R will cancel pi and 1 are there. So 2 multiplied by 2000, it will be 4000 all over. Remember, R has cancelled 1 R. So instead of R squared, we now have what? We now have R. So here's our surface area now. Here's our surface area. Now, moving on to the last question. Determine the radius of the tank if the amount of sheet needed to make the tank is to be minimal. Remember, what you fill inside a cylinder, it is the volume. But what you are covering a cylinder with, now we're talking what? We're talking surface area. So here, remember, this cylindrical water tank is made up of what? It is made up of a sheet. So when they say if the amount of sheet needed to make the tank is to be minimal, it simply means that we are talking surface area. If they were talking about what is going to be filled inside the tank is to be minimal, then we will be considering what? The volume. But here they are talking about what? The amount of sheet needed to make the tank, which is what? Which is the surface area. So that simply means for the third question, we're going to use what? We're going to use the surface area. And if they say if the sheet needed to make the tank is to be minimal, remember, maximum, minimum, we use what? We use the derivative. So we have surface area is equals to 2 pi R squared plus 4000 all over R. So we're going to use the derivative of what? Of the surface area of this. And then remember, minimum and maximum, that derivative, you equate it to 0. And then you solve for the unknown. So we're going to find the first derivative of the surface area, equate it to 0, solve for R, because we are required to find what? To find the radius. So we have surface area prime, which will be, you differentiate this, it will be 4 pi r. We are differentiating this the surface area with respect to what? With respect to r. So it will be 4 pi r. When you differentiate that, it will be minus 4. Let me make it very easier. Before you differentiate, let us simplify this. You have which is going to be 2 pi r squared plus 4000 r to the exponent of -1. Remember, for it to be positive, it will go to the denominator. So if you are differentiating with respect to r, then you will want to start here first. So now let us differentiate, which is equals to what? You differentiating with respect to r, it will be 4 pi r. This one multiplied by 4000, it will be minus 4000. From that -1, you minus 1 again, it will be minus 2. Minus 2. This is surface area prime. Surface area prime is equals to 4 pi r minus 4000 all over r squared. Look at it, it is negative, therefore for it to be positive, it has to go to the denominator. And remember, maximum and minimum, you equate what? You equate this to 0. You equate this to 0. So we are going to have 0 is equals to 4 pi r minus what? 4 pi r minus 4000 all over r squared. Remember, we're solving for r here, so we're going to take out r as a common factor there. 0 is equals to r into 4 pi minus 4000 all over r cubed. All over r cubed. We have taken out r as a common factor. You multiply with this r inside the bracket, therefore r will cancel 1 r there, you will be left with r squared. Let me quickly finish it off there. This is C continued. C continued. So you have r is equals to 0, or you equate this to 0. R is equals to 0, or you have what? Or you have 4 pi minus what? Minus 4000 all over r cubed is equals to 0. So we're going to have what? We're going to have 4 pi being equals to 4000 all over r cubed. I've transposed this one to the right hand side. So I'm going to cross multiply here. I'm going to have r cubed is equals to, you just interchange these two. Interchange these two. R cubed is equals to 4000 divided by what? Divided by 4 pi. Remember, we're solving for what? We're solving for r here. Therefore, we are going to take the cube root on both sides. Cube root on both sides. So r is equals to what? R is equals to the cube root of 4000 all over 4 pi, which will leave us r being equals to 6.827. 6.827. I think we can say this is going to be r is equals to 6.8 centimeters. 6.8 centimeters. So we have two values of r here. We have two values of r here. Now let us check. Remember, they said for the amount of sheet needed to make the tank to be what? To be minimum. So when you substitute 0 here, r is equals to 0 here, it will make this whole thing to be what? To be undefined. So in other words, r cannot be what? It cannot be 0. Therefore, this is our final answer for the radius of the tank. This is the radius that is needed. This is the radius of the tank if the amount of sheet needed to make the tank is to be minimum.